Hey, what's up guys? My name is Alex and I welcome you to another video. Today I will test LLM models and the performance on retrieval of the information from the large PDF files. So for the purpose of this video, I've got three very large files. All of them are about international AI safety and AI topics. So each file is around 300 pages. One is 2 megabytes, another one is 8 megabytes, and one is 4 megabytes in size. So in total, there are around 1000 pages between those three files. So I will use RAG using my software, and I'll just quickly show you what I'm going to do. So for the purpose of this test, I will ask the model to retrieve information based on this single line from this file. So we are looking on the page 184 of one of those files. So this file is actually the HDR 2025 report in English. So this is that file. It's 8.2 megabytes in size. So I will be asking the model to provide the details from this section, and we'll see how well it will perform using different models. So the question is here if it's best to use the RAG retrieval or maybe MCP to retrieve the information. So I can quickly show you the difference, how it operates, and how you need to set up your models to actually retrieve the information. We've got the software which I've created and I'm using for different purposes, and it gives us this token speed of each model and output and total output and input of the tokens that were used for each section. So in RAG settings, currently I've got token limit set to 4000 tokens per retrieval, and this is the maximum how much it can retrieve. This is a limited, this limit is set for smaller models, but it can be increased up to 16,000 for larger models. So let's for now set it to, for example, to 8,000, because first things I want to show you is to test the best models we've got. For example, Gemini 2.5 and Claude current model. So let's close that, and this is currently set to high quality, and everything is to retrieve as much information as possible. This is the window where I put the prompt for the agent, and we've got agents. In this section I can load different settings. So I've prepared three different profiles. One is to retrieve information using RAG, and one is to retrieve information using MCP. The difference is only the prompt and maybe a bit of the information they've got in the instructions. So we've got settings set here to 32,000 tokens for model context window, and this is enough information, but it can be set to around 6,000 or even less, because we're gonna use just one prompt and test how well it's performing to retrieve the information from the RAG. So the first model, first agent here, is that can be actually increased to up to 5 agents, and it can be set as a single agent, and all the agents can have their own instructions. And so let's load the RAG retrieval from single agent, and we've got a prompt for the agent that will retrieve the information. You are agent 1 retriever. Your sole purpose is to analyze the user prompt and retrieve the most relevant and accurate chunks of the text from the provided knowledge base using RAG. You should not synthesize, summarize, or alter the retrieved information. Your output should be raw, retrieve data that you believe best answer the user query. And we've got the second agent, which role is to assess the response and provide us with the score. So, and the score we're gonna use to actually know how well the agent 1 responded and retrieved the information from the RAG. And the agent to also got all this entire page section included into the prompt. So it knows exactly what the agent 1 should provide the information. So based on that, it can give us the score and the quality of the response. So to not hold you for much longer, let's see how it's performing. So we've got a prompt: search for details of smart system shared goals, the complementary or artificial intelligence and digital public infrastructure. And this is what it says in this file here on page 184. So and we currently, to retrieve the information, we've got the Anthropic Claude 3.7, and we can add any other models. I just need to type model here, but the Claude 3.7 is good enough for this test. So let's send the prompt. As you see, the metric score is just 1, 1, 1, 1, and it's completely failed. And this is because I didn't enable the rack. Let's do it again and send the prompt. So we've got the response now back and the retrieved information. The overall score is 4.5 of the 5. So metric score, retrieval precision is 5, and retrieval recall is 4. And we can increase, for example, number of tokens or give better instruction to increase this score. But let's test different model, and maybe we can test it again to see if the score will be the same, just for the sake of this test. This time the Gemini 2.5 Flash will be used as a reviewer. It's slightly faster. So we've got this back again, and overall score 4.5 of 5, and we've got very similar information. So on the second attempt, the Anthropic 3.7 Sonnet retrieved information with the score 4.5. And let's try to use the Gemini 2.5 Pro preview, or maybe 2.5 Pro just recently released. And let's send the prompt. As you see, the information received from the Gemini 2.5 Pro, looks like it's much more detailed, and there is much more information provided. So the speed of the generation was 42.9 tokens from the Gemini 2.5 Pro, and we received 13,491 tokens in total, including 12,000 almost of the input. And the score from the Gemini 2.5 Pro retrieval is 5. So we've got 5 on retrieval precision and 5 on recall. So the successfully retrieved the exact box 6.2 smart system, and no significant areas of improvement were identified for this specific query. So Gemini 2.5 Pro was actually able to retrieve all the information from this page. Everything is included in his response. So let's try Gemini 2.5 Flash. So we know that the score 5 is a top score you can receive, and in a second we will test the much smaller models, including the small local models running on the laptop. Before we do that, let's test the Flash and see how it's performing in this task. You can see it's a lot faster, so we've got 174 tokens per second, and from the Gemini 2.5 Flash on the retrieval, and the overall score is also 5 of 5, and every score is 5. So it's also retrieved all the information from this file and from this page. So the Gemini models are exactly very, very good models to retrieve the information from the internet. But what about the smaller models? So we've started from the very large models, and we will go down to very small models, including 1 billion parameter. So the score 5 is maximum, and let's see how the models, for example, let's use the maybe open router, and we can select any model. So let's use something that is 70B. So all the models 70B are listed here, and let's use the DeepSeek R1 for this test now. And let's send the prompt and see how it will perform. So the retriever is now DeepSeek R1 70B, but the Google here is only to provide us the summary of the retrieved information from the Agent 1. So not as much information as the Gemini is included in the response, but let's see what the assessment will be and what the score we can get from this model. So the overall score is 4.5 over 5, and Agent 1 correctly identified the primary source and the section 6.2, which directly discusses the smart systems. Areas of improvement: while the concept of public-private partnerships correctly identified, Agent 1 provided examples, etc. So it's not bad. 4.5 from the 70B billion parameter model. We can test another one, for example, maybe Gemma 3, if there is one available on this list. If it is not, maybe we can test it with Grok. I like this website. The models are extremely fast. Few hundred tokens per second can get from here. Let's test LLaMA 3.3 70B Versatile, and it's using Grok. So let's send the prompt. Look, the speed is very, very fast. So 155 tokens from the Grok on the retrieval and the response. Let's wait for the score, and we'll see how well it responded. So response was 3.5 score in general. Retrieval precision is 4, and retrieval recall is 3. Let's test another one. So we can maybe test the LLaMA 4 Maverick 17B 128E and see how well it will retrieve. So like when you look on the error, we requested 8,000 tokens, 8,192 tokens, but the maximum. Okay, I got what that means, and that means that the maximum tokens for the response is too high. So I need to set this to, for example, 5,000 to be below 8,000 maximum. And let's try again. So we've got the response. Now we are not using tokens over the limit, and it is actually quite good response. So 4.5 over 5, the overall score for the LLaMA 4 Maverick 17B, which is better than DeepSeek R1 70B. Let's try again if it will be the same. Again, we've got overall score 4.5 over 5, retrieval precision is 5, and retrieval recall is 4. Areas for improvement: missed out specific details from the ground truth box 6.2, but successfully identified and cited the exact relevant section title and page number. So it's not bad for the LLaMA for Maverick. We can now test maybe some smaller models like 24B or 33B. Let's try QWQ32B and see how it will perform. So 143 tokens response rate from this model from the Grok website, and we used in total 8,358 for the entire response, and we've got a response overall score 4/5, and retrieval precision is 4 and retrieval recall is 4, and the successfully identified summarizes core concepts of digital public infrastructure and areas of improvement. The agent included an example from the website, from the page, missed some specific details such as the mention of DPA, etc. So not bad for 32 billion parameter model. Let's maybe try LLaMA 3.1 8 billion parameter instant. (362 tokens per second response rate from this model. LLaMA 3.1 8 billion instant. Let's see what the score is. So it provided us with so much information, so it probably gave us all the raw information that was retrieved. The overall score is 4.5/5, so 8 billion parameter model provided us with so much information retrieving from the rack. And retrieval precision is 4, but retrieval recall is 5. So it's not bad for 8 billion parameter model, and just it gave us probably too much of the information that it should give us. But it's and then the next model inner row could probably clean that information and provide what we ask for if we add a middle agent into the process. So let's try another model, requesty, and we've got lots of interesting models here, and maybe we can try actually GPT 4.1 and see how it will actually perform. Let's see. 72 tokens per second retrieval rate from the requesty GPT 4.1, and let's see what the score. As expected from this type of model, overall score is 5/5, and retrieval is 5, and retrieval recall is 5 as well. So that's expected, as you will expect from the Google OpenAI. So let's try another different model. I actually tried the Claude 3.7, but we can try the Claude 4.0 using let's use a Claude Sonnet 4, and let's send the prompt. So we've got 4.5/5, retrieval precision 5, and retrieval recall 4. So yeah, this is similar to the 3.7 Anthropic model, Claude 3.7 we had tested at the beginning. So we can also test the LM Studio models. So I've got several models in my, and we just need to select one model, and let's test Qwen 3 4B. Let's test that. But to test those models, I need to increase the content length. So I will increase it to, for example, 20,000 tokens. Why not? Not keep the inner memory, so load it to the GPU and flash attention enabled. And let's load the model. So I am currently using okay, we've got the model loaded, and now we can select it from the list here. So we've got Qwen 3.4b, and we are using LM Studio Qwen 3.4b, and let's send the prompt. So this is running on a Ryzen AI Max Pro 395 and Radeon 8060 on HP G1A laptop that I've tested in my previous videos if you wish to see how this laptop and the CPU is performing using different models and different sizes of models. So we've got 17 tokens per second response rate from this model, retrieving the information. The response rate is a bit slow because it uses also the time to retrieve the information from the rack. But the overall score for the retrieval is 4.5, so similar to the Anthropic, the Claude models. So retrieval precision is 5 and retrieval recall is 4, and it is quite good score for 4 billion parameter model running on local machine. So let's now add an additional model. So let's load also the Gemini 3 1 billion parameter, and let's see how it will perform. So I will increase that also to 20,000. Don't keep it in the memory, enable Flash and load the model. So we'll have two different models loaded, and now we can, let's retrieve. So I've got 27.5 tokens per second retrieval rate. This is including very large input, so 5,000 tokens as an input for the prompt, and the overall score for the retrieval is just 3. Retrieval precision is 3 and retrieval recall is 3. Successfully identified the core complementary between AI and digital public infrastructure. Correctly extracted the example of Stripe using AI. Areas of improvement: introduced inaccurate information by stating AI is being used in automotive manufacturing, so it's got some hallucinating already, and missed several specific examples and details from the provided context. Okay, before we finish, let's also test the DeepSeek, and let's see how it will perform in responding to the rack information. Let's send the prompt. So we've got again limitation of the tokens set for the DeepSeek, and it was set automatically to 32,000, and I will decrease it to 6,000, and we will get a response. So we've got a DeepSeek response, and the score is 4.5 over 5. So the retrieval precision is 5 and the retrieval recall is 4, and it's quite good score, similar to the Claude. And from my test so far, it looks like that Google is the best model to retrieve the information, because we are getting 5 score all the time. So let's try it again and see how it's performing. You can see it's clearly much better response when you're using Google to retrieve the information from the rack. And I'm sure it will be 5. Oh, actually we got 4.5 over 5. So retrieval recall for 5, and we've got the precision 4. So this time it's a 4.5, but I like how the information is provided. And of course, the settings we've got in here makes big difference. So if I change that token limit to 12,000, for example, I can just select the high quality, and the maximum will be 12,000 tokens for the rack to retrieve. And the number here, it's also make that big difference. So it's just important score. Higher score means the less retrieved information and more relevant information is retrieved. The lower score, you get almost everything retrieved, and then the agent can pick up the information you are actually interested in and provide it to you. This depends on how much tokens you want to use probably and how much information you want to retrieve from the document. Let's go back, and before we finish this video, I hope you like the test I did so far. If you want to test me any other models, or maybe combination of the models, I did the tests where I was using the one model to retrieve from the rack, and then the second model was actually retrieving using MCP from the file, and then third model is just to summarize all the information and provide you with everything that you're looking for. And this is a very simple to do in this way with this software. I want to show you the difference between the retrieval with the rack and the retrieval with the MCP. So I've got another profile to retrieve information using the MCP and in similar configuration. So we've got now information found by the model Atropic found the information on this page 184, and it found actually the section that we are looking for. There is no need for me to read it, but and the score is 4.5 over 5. So if we want to tell the model, okay, look for the information in this file, and we know what we are looking for, then the MCP is another option to actually look. But we can combine the MCP and the rack, and this will provide us even better. If you want me to test this, I can create another video, because this video is getting already too long. I was hoping for this video to be 10-15 minutes long, and again, I'm just taking too much of your time, guys. Okay, guys, thank you for watching. I hope you like today's video. Please consider subscribing to my channel, and if you want me to test the settings, do the similar video, but using the MCP and searching inside of the files for the information, and maybe searching, and we can also do the video where we search and write to the files. For example, with this software, it's possible to search for the files in the project actually folder and retrieve the information, for example, one of the project files, and write back to the file and the information that we want to change. But this is a topic for another video. If you like to watch it, if you like me to do the video like this, please let me know in the comments, and remember to subscribe to my channel if you want some more videos of this type I will be doing in the future. Okay, guys, thank you for watching, and I will see you in the next one. Goodbye.